Today's episode of Robotics Programming is going to integrate all our hard work from our previous two labs where we learned servo control and how to use our ultrasonic sensor. It's going to enable our robot to sweep its head and to get distance readings from objects all throughout its environment. This is the last video where we're going to concentrate on the hardware build, robot dynamics, and managing all of the actuators and sensors. From here, we're going to use this data to create really awesome algorithms like PID, localization, object avoidance, goal setting behavior, and more. The goal is in sight. Let's dive in head first. Today we're going to be integrating our code from video 2 where we worked with the ultrasonic sensor with video 3 where we worked with the servo. The first thing I have to note right away is that there could be a problem overlapping libraries using the same timer on the Arduino. This is going to be particularly important for those of you using the Polu 3 Pi Plus, but it could be a problem on other robots as well. I want to explain what this is and why it's happening, and then we'll see how we fix it. So the first thing is to describe what exactly the problem is. Just like we've been using millisecond timing to determine when we take some action, like move the servo or check our encoders, our libraries do that too, and that's really good programming practice because we don't want to be using delays in our Arduino programming. If you're seeing the symptoms of this, I want to describe them so you know what you might see. The servo will usually go hard to one side where it will constantly push at its limit to one side of the servo's range, and you got to be careful not to leave it running like that because it can actually chew up the gears and ruin the servo, especially with plastic gears on the servo like the 9G that we have. So to fix this, I'm going to go to the Polu documentation here and follow along. So here we are on the Polu website. I'm going to leave this link in the description. And the first thing we need to do is locate your servo library so that we can alter one of the files and use a different timer. Now, the first challenge here is to figure out where your library is. There's a very good chance that it's in a libraries folder that is a subfolder of your documents. The real answer is it's wherever you installed the libraries when you went ahead and did that. Now, you might not have given it any active thought if you went with the defaults, but you might have to use your Finder or your Windows Explorer tool to search to find this file, servo timers. It is also possible that you might have more than one if you've installed different libraries over time. So it's very important that you locate the correct one. I have my documents here, and I have an Arduino folder in Documents, which has a libraries folder, and I have a bunch of libraries in here. You may or may not have the same or more than I do. But in there is my servo library, and in there is the source and the AVR folder. Notice that we are in fact in the AVR folder here, as that is the actual architecture of the chip that I'm using, and not in any of the other ones. And in there is servotimers.header. So let's go ahead and open that file. So now that we're here, it's very important to look for the else if that defines for the AVR ATmega32U4 chip. We don't want to change this for other chips because this is the one that my particular 3 Pi Plus is using. We're just going to come in here and change this use timer 1 to be use timer 3. And then this timer 1, that's part of the enumeration here, to be timer 3. I'm going to save the file, and that's it. It's all set and ready to go. I'll know this was successful because both my servo and my motors will be able to work at the same time. Beware of a symptom where your servo goes hard over to one side and tries to basically break past its limit and the wheels on the robot are just turning lightly. That would be a sign that this is not fixed. All right, so now that we have that addressed, let's go ahead and go through the code. Again, most of this code is taken from either our second video or our third, so please make sure to use them as references, and I'm not going to go through every detail as I did there. The first thing I want to point out is that I have a couple of more debugging booleans here that I'm going to use to turn on and off different debugging so that we have a nice clean log to look at. And the first one we're going to look at is this timing, because we're going to use that to help ascertain the timing of moving the motor and then making sure that we send off the ping for the ultrasonic sensor and give enough time for that to come back before moving the motor again. We'll talk more about that process in just a moment. I also have an ultrasonic debug, which is going to show the contents of the array that keeps all the distances at the different angles that we turn the servo to. I also have a couple of booleans here. I added these to turn on the servo and the ultrasonic sensor
when we're using them. I'm going to go ahead and set those to true now. The reason why I did this is sometimes I like to leave the robot connected to USB power while I'm working with code and debugging, and it can be a little bit annoying if the servo is constantly moving around. There's also now our head servo timing, which hasn't changed, but I have changed the head movement period a little bit. I've upped it to 120. Now we're going to be incorporating also the time it takes for the ultrasonic sensor to send out its ping. So I'm going to show in a moment that I have another variable that kind of separates these two things, what part is the motor movement and what part is the actual sending out the sound and waiting for it to come back. But this is the overall period that encompasses both of those actions. We have here the head positions just like we had before in the servo video, so we're going to reuse that. We also have our direction and our position. This also follows suit with what we did in the previous video. We are initializing our ultrasonic on the same pins that we did in the second video. And I'll talk a little bit about what we are doing here before we move on. So I've set a max distance, this is in centimeters, that I feel that I care about data within. So if, for example, the ultrasonic sensor picks something up at 3.5 meters or 4 meters away, I'm not going to care about that information. I only care about information that is 3 meters or closer. It also means that I'm going to initialize my array to this 300 to start, because you don't want to initialize your array values at the different angles to zeros, because remember, we're going to take a magnitude from this distance, and that magnitude at a 0 or a 1 or something like that would actually be a really high magnitude. And if you started the robot and it hadn't done a full sweep yet, it would actually freak out a little bit because it would think it's surrounded by objects. The other thing I'm doing here is I'm creating a distance factor. So what I want to be able to do is change this on the fly. Let's say I decide 3 meters is too much and I want to change it to 2 meters. Well, that might mess up my math further down. If I do this, where I create a distance factor, taking this, like say our 200 now, and dividing by 100 would give me a distance factor of 2. And if I apply that to whatever math lies below, then all of it will still be linear and respond the same way regardless of how far my max distance is. I'm also creating a stop distance here. This is intended to say below 5 centimeters, I don't really care about this data because I don't trust it. The ultrasonic sensor has a minimum distance. I want to say it's 4 centimeters, but in my testing, I've seen 5 is pretty accurate, so I'm sticking with that. Our ultrasonic timing here is very similar, but this one line here deserves a little bit of discussion. So earlier, we set up here that we were setting our total time for both the head movement and the ping of the ultrasonic sensor to 120 milliseconds. Now this is where we separate out what part of that is the motor moving versus what part of that is the actual ultrasonic sensor's ping. So remember, we don't want to start the motor moving and send out the ping at the same time, because the motor is going to be in motion, and even though we're not going very far distances and the speed of sound is relatively quick, the motor is not going to be in the same position it was in when it sent out the ping when the ping comes back. So we want to make sure that we actually start the motor, give it enough time to get to its destination, and then once it's at its destination, send out the ping. So that's what this does. Out of that 120, we're saying 80 milliseconds is going to be the movement of the motor. The remaining 40 milliseconds will be the time we have for the ping to come back to the sensor. This flag here is also going to be helpful because it's going to prevent us from accidentally setting a ping more than once, and this will be the array that we actually use to maintain the distance readings for the last known distance at each position. So if we look up here at our actual positions, we currently have 7 of them, ranging from 135 degrees and moving in 15-degree increments all the way over to 45 degrees. So this 90 here is dead center. So this distance readings now, notice it's initialized to the same size as the total head positions. This will retain the actual data collected at each of those angles. All right, we've made it through our constants and our values, let's look now at our setup, which is pretty straightforward. This is following along with what we've done in the past. We have our serial begin for debugging. We attach our head servo just like we've done in the past. I have here a value. I'm going to actually change this to 90 to stick it in the center, but that's just a place to put it when it first turns on. We're also then going to initialize our ultrasonic pins, and this is now where I set the max distance by default to our distance readings. We then just wait 3 seconds for all of this to happen, make sure that our motor gets into the right spot, and then we play a note. And this is more for, again, the programmer, so that we know that the robot, when it's not hooked up to our cable for debugging, has completed its setup and is moving on to the loop. Now within the loop, we have our 2 methods here that we did in the last 2 videos. We have our read ultrasonic sensor, or read CM, from the second video where we worked with the ping on the ultrasonic sensor, and we have our move head from our last video where we worked on moving the servo. Looking at our move head function now, this is pretty much what we've seen in the past, where we're waiting for that head movement period, the 120 milliseconds that I had assigned it, to elapse before we go ahead and run this code. Once we do that, we have a Boolean switch here to make sure, again, that I only want to turn the servo if I have that Boolean on. This is my way of preventing the motor from running when I don't want it to. But normally this would be set to on if we want it to actually work. We then go through our head position. We have some debugging here. This debugging in particular will be important today as we look at the timing component. This is where we're actually going to say that, yes, we started moving the head. It hasn't gotten to its destination yet, but it started moving. Then we also have our code down here to deal with the rotational properties, to make sure that we have our limits on clockwise and counterclockwise, and that they match the number of head positions, and that we move the head into the next correct position, coming and going. Again, this code was discussed in depth in the last video. The only thing that's new here besides what we discussed earlier is this US read flag. Notice here now, this is a little bit different from what we've had in the past. We don't have just a ultrasonic millis or something like that. We have the wait for after head starts moving, which you might remember is currently set to 80 milliseconds. So what we're saying here is once we actually get the head's previous movement and combine that with the 80, so 80 more than the head previous millis, which would have been set here when we actually started the motor moving, when the current millis is greater than that, so in other words the 80 milliseconds has elapsed and this is false, then we go in here. Now you'll notice that we set this to true inside here, and that's so that we don't accidentally set this off again and again and again and again. We needed some way to make sure that once this condition was true, we only set this off once. So that is the purpose of that flag. Now notice that we have this timing debug here. We're going to note that we initialize the ping. You might remember from our previous discussion that the ping itself is a blocking call. We will be in this function until this pulse in returns. And remember, we are setting a limit on that as we discussed before. So this is actually set to 30 milliseconds. So I've actually baked 10 milliseconds extra in here because you might remember that I had 40 as a difference, and that's not explicitly necessary. But you know, it's good to have a little bit of buffer. So I also have my limits and everything else like we've discussed in the past. This is how we apply max distance and make sure that we don't get an error in the reading because it comes back with 0. This is where we apply the distance to the array. All of that is pretty much in line with what we've done in the past. The only difference here is that we're applying the distance to an array and not to just a global distance that we're going to use. That's one distance. Now we have multiple distances, one at each angle that we read. But then we have our timing debug here where we see that, yes, in fact, we did get the ping back, and that is the amount of time that's going to have passed since that happened. So we should see all of this in our timing debug when we set it up to run. We have our then debugging for the ultrasonic. This is going to show us the full array, and we set that read flag to true. All right, so we have everything set up. Let's go ahead and fire this up and look at the timing because I want to show how that actually works. So the first thing we want to do is set our timing debug to true so that we can see these timings and make sure that the motor moves and then the ping happens and then the motor doesn't move until both of those things have happened again. So we're going to set that to true. We're going to verify here and then we're going to upload our code. There you go. So it's running, and this is running a little fast, so I'm going to stop it. I'm going to scroll up. You can see here that it started at 3 seconds in, which makes perfect sense. It waited 80 seconds before it did the first ultrasonic read. That's where the motor's moving between these 2 points. And then it took 4 milliseconds for the ultrasonic read to finish. You can see that that varies though. Like this one was actually 11 milliseconds. This one was 8. So what we want to look for there is that we're providing enough time. Now I could probably shorten mine a little bit from the 40 for sure, but like I said, I'm leaving myself a little bit of baked in extra. But the important thing is that all of these things happen in sequence. The head starts moving, we give 80 milliseconds for the head to actually reach its destination, then we start the ping, then we get the ping back, then after that, the next head movement starts. You also might notice that there might be a way we could tighten this up, because if we actually notice that we get the ultrasonic ping back, then there's no reason why we have to wait that whole 40 milliseconds, and maybe this 3121 could have been 3086, and we could have started this a little bit sooner. But you get the idea, and you can definitely refine it a little bit better than I have. The important thing is to make sure that you leave enough time for the head to move, stop moving, and then register the ping. All right, so the next thing I want to check is the ultrasonic output itself. So I'm going to turn off the timing debug because I want to keep my log nice and clean, turn on the ultrasonic debug and upload this. And we're going to get these distance readings here that will tell us what the output is, what the actual distances are that we're seeing. Now I've put a box in front of it there, and you can see that it's about 16, 17 centimeters away, give or take. If I move it a little closer here, you can see that that goes down 15, 12, 11, 10, right? So 9. So that is working well. You'll also notice that the side readings are a little bit back and forth because it's kind of sitting on my desk and there's not a lot of good obstacles in front of it that are solid. There's some good distances there to the wall and such. But this gives me a pretty good feel for what's going on. And I can move it to one side or the other. So if I go towards the left side of the robot here, you can see that in fact it does change there, and I can even move it in on the left side, and you can see those numbers in the early part of the array going down, the 0 and 1 element. If I move it back and across, if I move it over to the right side of the robot, now you can see that in fact those distances have changed, and now it's over there, and I can move it in and out. And you'll want to do this. You'll want to check that each element of your array is actually giving you back the information that you think it should. Now, these numbers are fairly consistent. In this box is a pretty good obstacle. But one thing I want to point out is that we don't have to stick with these ranges. So, for example, we only have 15 degrees here between these, and you might notice that there's a lot of overlap on where it sees the box. It's not just one of these areas, it's a lot of them. So let me even back it up a little bit here, and it's still probably going to see it for quite a bit of them. So the entire center there sees it, the first 3. Let's go ahead and change this a bit. I'm going to take my head total positions down to 5, which means I don't need that, I don't need that, and I don't need that. And I'm going to also change how much is in between. So I have 15 degrees now. I'm going to change it to be 90. So let's do 110. Whoops, sorry, this is going down. So let's do 60 and then 30. And then up here, we're going to do 120 and we're going to do 150. So now we have 30 degrees between each. Let's go ahead and upload this. All right, there we go. Now, you can see now we're actually only seeing it consistently, at least in the middle. Now, if I move it in closer, it's obviously going to pick it up in the center more, and it does. You can see that it's more to one side. I can move it back and forth, and that's going to change. but it's a lot better. I think this might be a better setup, but I'll let you play with that. I mean, the 7, the 5, you could do 3, you could do wider angles, smaller angles, whatever it is, but you want to make sure that everything's working pretty well. Please subscribe if you enjoyed this video, and I look forward to seeing you again in the next Robotics Programming Lab.